Hi, this is Jacob Staples. I'm Rampart-Al's Chief Technical Officer, and I'm going to be walking through a demo of using Rampart's Container Runtime Security Agent to protect a containerized deployment of a Quake 3 Arena server running on Elastic Kubernetes service. So let's jump right into this. Here's the architecture we're going to be working with. Essentially, what we have is a couple of different layers of abstraction, and I'll try to highlight the cut points where our agent comes into play. At the managed infrastructure level, we have an Elastic Kubernetes service and managed control plane that our infrastructure is kind of relying on. We have an Elastic container repository, and that's where images used in the scenario are stored. We have some nodes as part of our Elastic Kubernetes service cluster running on managed EC2 instances. And so in this case, we just have this diagram. There's 3. In the scenario I'm about to spool up, there's actually just 2 of them. And then on each of these nodes, we have one Rampart CRS sensor. So there's one container runtime security agent running on each of these boxes. And then those agents are watching all of the pods that are being executed, and I'll walk through that in just a moment for our Quake stack setup. Then our pods are exposing a service, which is load balanced using ELB, and that's how external users can interface with our system. Now, behind the scenes, the Rampart CRS agent is watching everything these containers do, and it's comparing what it sees to a set of known good behaviors for those containers and those pods. And if there's any kind of a discrepancy, it ships that as a notification off to the Rampart SaaS. And the Rampart SaaS can make a determination about how bad it is and any remediation action that needs to be performed as a result of that. So for example, if it's a particularly horrible thing happening, like an outbound network connection, which could be indicative of some kind of an exfil attempt on data inside of our environment, we can go ahead and block that. Or we can just warn and alert you to the fact that it's happening. We also have behind the scenes a number of scanning daemons running, and these things are continuously looking at both internal and external repositories of container images. So your containers are instantiations of images, and we can scan those images and pick up on CVE cross-section to figure out what's inside of them, what's running, and build up a continuous living inventory of not only what's available to execute in your production environment, but what's actually running. Sometimes that can be very telling, and we'll talk more about that momentarily. All right, so here's a screenshot of this thing when it's actually working. I kind of gave you a brief overview already of what container runtime security is. So let's talk about actually doing this thing. So first thing I'm going to hit is the Rampart command and control interface. So once I've logged in here, in this case I have some kind of a test admin account, then I'm able to log in and start doing interesting things. The first thing that I'm going to do is I'm going to pick a workspace. In this case, I'm already active on the cube test workspace. Once I'm inside of a workspace, I'll see a number of contexts, and these are essentially different configurations for sensors. So different organizations might want to have a different set of sensors that configured in different ways, and this is a way of managing that abstraction. What I'm going to be doing is using the cube stack setup today, and I'll show you what that entails momentarily. But essentially, that's going to be shipping telemetry into an Elasticsearch instance fronted by Kibana, and so periodically I'll shift over here and show you telemetry that's getting cross-shipped by our agent into that environment. One of the things that's interesting about this is that in order to interact with this endpoint, in order for your telemetry to flow into this endpoint, you have to acquire an X509 client certificate. And so that's what this functionality is right here. So you can click that, you can pick an expiration date, and you have to set a username, or sorry, a passphrase that is a secret essentially that you keep hold of. And then you can download the certificate and then use it to ship telemetry via our agent to the Polyglot server when you're actually running this thing for real. Okay, so once you've got your client certificate, which downloads as a binary file, you can base64 encode the certificate part, and it's going to be a rather lengthy string. You take your password and you base64 encode that, and you can store it inside of a Kubernetes secret. There are other ways of doing this that are nicer, more secure, but this is a very simple thing to do for a demo. So that's kind of the way we're doing it in this scenario. All right, so let's talk about rolling out the Rampart Container Runtime Security Agent. Our goal is to make this as minimally invasive as possible. So what I'm going to do is I'm going to switch over to a terminal that I have SSH into a demo environment. There's a number of scripts in play here. What I'm going to do is I'm going to insert the Rampart CRS agent into this infrastructure. And I've already got a stack stood up with my 2 compute nodes in my cluster. So what I'm doing right now is I'm using Helm to roll out a sensor called Tetragon, which is a way of gathering eBPF telemetry from a Kubernetes environment and map those telemetry items to containers. And our sensor sits downstream of that and intercepts what Tetragon is producing and uses it to compare what we see in a container at runtime and production versus what we expect that container to be doing in production. All right, so that's all that it takes. Again, I ran a single command and this runs the daemon set. So it rolled out my Rampart agent daemon set to both of my compute nodes, and now they are both active and ready to go. So, running a single command can distribute this thing to a large number of nodes depending on the size of your cluster. That's a nice thing to have. Once we've got this thing deployed, the next step in this is to start. There's some information here about. We can dive into details offline in a blog post essentially, but the interesting part now is going to be rolling out the demo app. Okay, so like I said before, this is a Quake 3 Arena server, and this is all based on an open source Docker image. What I'm going to do is I'm going to spool this up using kube control create TACF, and that's going to deploy essentially this architecture. So there's going to be 2 different pods, each of them in a different namespace. We have the Elastic Load Balancer, which will get some random URL that we can access this thing by on port 31337. We have our Quake proxy namespace, which essentially contains an Nginx container. And that's what sets up our self-signed X509 server certificate that gives us HTTPS on this endpoint. And that's going to proxy traffic into a Trey Yoder Quake.js Docker container, and that's inside the Quake server NS namespace. And that's exposed to this other namespace internally via this Quake.js-svc service definition. And again, this is sitting on top of 2 different nodes running on EKS. So after I've rolled out my sensor, which in fact I've already done, we have this other component here, which is running in the kube system namespace. It's on there is our Rampart CRS sensor, and it's watching what Tetragon's picking up out of this box. And that's how we're going to get interesting telemetry out of this scenario. So let me go over here and deploy this thing. Go ahead and run this deploy Quake.js command. It's going to create 2 namespaces, a number of different items here, and that will pull out our architecture. And we'll have to wait a moment for the domain name that's created by the Elastic Load Balancer to resolve, because those are dynamic. Sometimes they take a moment or 2 to become a map to an IP address. So we're waiting for the rollout to happen right now. We're waiting now for the load balancer host name, which has been assigned to our endpoint, to resolve locally. Like I said, that can take a moment or 2, but usually it's not too bad. And then once that's resolved locally, I'm going to start interacting with the endpoint, and I'll kind of show you how it goes. Now, meanwhile, let's look at some of the telemetry flowing out of the system, because now it's actually doing something interesting. So I can go over here to my event view, and I see some blips here. And essentially, this is saying that there are some sensor components that are unknown right now. These are nodes inside of our architecture that haven't been seen before. And those will become resolved over time as the scanner picks up on new pods. It will start kicking off offline asynchronous scans of this thing. All right, so it looks like our host name has in fact resolved now. So let me try to copy this thing off of here. Okay. So I get this message every time because this server-side X509 certificate gets regenerated randomly every time the server is deployed. So I'm going to go ahead and proceed to this endpoint, even though I know that's a little bit janky. There's this license agreement. I'm just going to agree to it. And again, now I'm accessing essentially the Trayoder Quake.js image. Now it's doing this thing where it's downloading a large amount of information into my browser. And this is a couple hundred megs worth of JavaScript and WebAssembly that implement the Quake 3 Arena game client entirely in browser. So some enterprising individual was able to cross-compile the original C and C++ code base using this mscripten tool entirely into JavaScript and WebAssembly, and that's what's being downloaded right now onto my laptop. So that's being served to me on the server side inside of that Trayoder Quake.js image by an Apache 2 instance. And again, that's all fronted by that Nginx thing running in a different namespace. And this is all flowing into my browser without any special execute thing being installed. So it's pretty cool stuff. And I'm going to mute this because it gets very noisy. But without further ado, now I'm playing this game from 1999 that has a certain amount of nostalgia associated with it. Don't claim to be terribly good at it, but good enough to prove that it's working. And you can see the ping's not great. I'm running this on a server that I would expect to get a ping of around 80 or so. So 95 is not outside the realm of random network fluctuation, essentially. But the point is that despite having this sensor component running that's monitoring all of the system calls on this box, it's still very performant, right? Like I feel the lag of the game because it's an older game that doesn't have great net. As I kick off the next step of the demo. Okay, so the next thing I'm going to do is I'm going to do something that kind of indicates what a rogue admin would do, or someone who's able to break into an endpoint and run remote command and control on the endpoint. What I'm going to do is I'm going to use a kube control exec to go into this box. And what I'm going to do is I'm going to just run bin bash. Okay, and then I'm going to use bin bash to steal a secret file from this environment and do something horrible at that point. Okay, so I break in. And again, in this case, it was just the kube control exec from within the Kubernetes control plane. But in the real world, if this was an exploit that I was running, I would have achieved this through some kind of a vulnerability that led to remote code execution. So I'm kind of just taking a shortcut to show you what happens if you break into this box. So let me just run some commands here that obviously aren't terribly interesting, but they'll show up in the logs. That's the important part. So I go back here to my telemetry dashboard, and we'll watch this closely, and momentarily we should see some alerts pop out of this thing. And get this thing to get off the top of my screen here. Okay, so go and I look at the events here, and we see that the origin source of this information is the tetragon sensor, like I mentioned before, that's capturing eBPF. We see the kind of like the environment this thing came from. It came from a Kubernetes environment. We see the namespace within Kubernetes that it was running in. The workload is a deployment here. We see the name of the pod. We see the image name. We see the image identifier, which includes the full unique SHA hash that identifies it. And then we see, of course, the thing that happened. So here I see my cat YOLO, and the system call type is a process exit. There will be a corresponding entry point, obviously. And it's this one right here, the process exec. And here I see my cat YOLO again. So basically, for a long-running process, you would see an entry and not an exit. But because this was a pretty quick thing, we just see the entry. Now, there are two of these that show up right now. And we will wait momentarily. We'll see some CVEs pop out of this thing. But let me shift gears here and go back to this view. And we should see those show up momentarily. And they do. So in this view, things are partitioned a little bit. In our Rampart UI, things are kind of shown in one graph, and you can click on different widgets to filter. Here, they've been kind of stripped out and spread apart a little bit more, flattened, if you will, to make the information easier to look at. So that's the value of doing this in your own sim or your own dashboard, because you can design the UI however you want. So that's one of the values of cross-shipping the telemetry. All right, so that's the system running. Let's look at a couple different views here to see what this looks like. So if I go into my image inventory view, this is a list of all of the, within my context or within my workspace, I can see all of the different images that have ever been executed. The server. So Archon password will allow me to run commands inside of the game client in my browser. So knowing this secret string right here is a really bad thing. Knowing this secret string here is a really bad thing for anyone who's running this endpoint operationally, right? Like only the admin of this box is supposed to know this. And here's why that's interesting. If I go back into my endpoint. And sometimes I have to refresh this if I've been away from it for a while. So wait for it to reconnect. And the bots have been busy while I've been talking. Yes, we're on a different map now. So if I type in Archon status is the command, and test would be the password here. It says bad Archon password. But if I type in Archon I do the exact same command, except I provide the correct password that I just dumped out of that cat. Now I see all of the players. I see their IP addresses where they're kind of ingressing from. And these will apparently be, from the server's perspective, the IP address of an Nginx node, just for the record. That's why it's this 10.0 thing. But anyway, I see player 6. That's me. So what I can do is I can actually kick myself. Let me just up arrow this. Kick player 6. And this indicates what, someone who's using their admin privileges could do. And I just got kicked out of the game. Now, of course, in this case, it's kind of silly because I can always go up to my browser and immediately reconnect, right? So the next step in this escalation would be to ban the person, right? But that's not terribly interesting. So if I go back here to my event view, I see that there's a number of events that have popped out of this thing now. Okay, there's my grep command, and there's my cat. So it's picking up essentially every command that I run on target. And again, this is not limited to commands. You can also pick up on things like network connects and listens and all kinds of system calls. You have to be careful in what you're tracking, though, because doing the wrong set of tracking operations can lead you to become invasive in terms of performance. So if you start tracking too much stuff, like every file operation, for example, you can just absolutely destroy the performance of your endpoint. So we've got a minimal set of rules in place right now to track commands and track suspicious network activity. And that's essentially what you're seeing here is the commands being picked up. So anyway, the thing that I said would happen has finally happened. We've got our list of CVEs that have finally been picked up inside of this container. And again, that process gets kicked off when the container launches, but we just got a fresh scan back. And it shows all of the events that have happened in terms of CVE. So what I can do is I can filter by major category here. And if I want to, I can just see the tetragon stuff, but I just want to see the CVEs. And then you can dive in all the gory details and see all of the problems in this deployment. So integer overflow found in the Linux kernel. There's all kinds of stuff that this is susceptible to. So basically, this is a dynamic event that indicates to you that you are running something that has a known vulnerability cross-section. There's another flavor of this event that gets kicked off periodically by the server, and the server will say, all right, I already told you about these, what is this, like roughly 700 CVEs. But if a new one emerges during the application's lifetime, that asynchronous process will say, hey, just a heads up, not only were you susceptible to those other 650 or 700 things that I told you about, but here's a new one. And because it's new, it gets a separate event downstream. That happens within minutes of it being released in public repositories. So that's a pretty useful thing to have. Now, if I go back to my image inventory view, another thing I wanted to point out that I kind of glossed over before, you can also download SBOMs, bills of material in SPDX format or CycloneDX format, or you can just view them in the browser. It's not terribly beautiful, just lots of JSON essentially. It gives you information about all the layers and what's inside of all the layers inside of the image. And then, of course, you can also look at the CVEs themselves, and this is interesting also. So this gives you kind of like a retrospective view of when things were running, and you can kind of look backward in time and say, given the like future discovery of a CVE that I didn't know about when I deployed my system. 6 months in the future, could I look back in time and say, was I vulnerable to that thing? And that's a hard question to answer today, right? Like a lot of man hours have been spent trying to figure out whether stuff was running during these critical windows between when something was discovered and when it was patched. And Rampart gives you a very quick way of answering that question. And in this case, you can answer it directly through our user interface here, or you could go into Elasticsearch or wherever our telemetry is being dumped and run custom queries there and get the same answer back. And then I didn't talk too much about the dashboard views, but we have different ways of aggregating and showing this information. There's a context-oriented view, which again, I'm running in the cube stack context, and you see all the list of things that have happened here over time. And then there's an image-oriented view, which is showing things that are running. And so I see my 2 sensors that are running with no issues. These are essentially the Rampart container runtime security agents. And then I have my Trayoder Quake.js image, and I have this Nginx thing, which the scan for that hasn't happened yet, but when it does, we'll see those vulnerabilities that I saw in the other view. And then there's a run-oriented view, which shows you things that are running over time. And the runs are essentially container identifiers. But if you need to, you can dive deeply into this and see which problems emerge in specific containers. All right, so this is really only scratching the surface. There's a whole lot of extra stuff that Rampart does that I'm very much glossing over the surface of. But hopefully that gives you a very quick idea of how easy Rampart CRS agents are to install into an existing Kubernetes environment and the value that they can give to you very quickly with minimal effort on your part. So thanks for watching, and stay tuned for more of these demos in the future.